any questions people have about the technology.
Sorry about that, Aaron. I just forgot to put the record button.
Okay, there we go. Just had to acknowledge that. So yeah, let's talk a little bit about kind of the history. Won't get too in depth here, but keep it kind of brief on the history here at Maptek. But essentially, Maptek was founded in 1981 by Dr. Bob Johnson. He's a geologist. He created the Vulcan GMP general mine package in about 1984. And eyesight software, which is point cloud processing that we're going to talk about, and I'm kind of going to show a little bit of that today. That was established in 1998, and then subsequent in around 2003, 2004, that was the first generation of the terrestrial LiDAR scanners at Maptek, and later it was in 2018. Eyesight Studio, the point cloud processing software, was rebranded to Point Studio. So that just came along with a lot of major changes to the general user interface, and the application platform that it lives on. So that is actually the Workbench platform. That'll make more sense when I kind of show the Point Studio software, and I'll show that to you guys. We'll kind of jump into that live. So for today, we're kind of going to focus on kind of one area. As mentioned, it's really more on the terrestrial LiDAR side and Point Studio and the slope monitoring software. So kind of highlighted in red there, that's Point Studio, scanners, and Sentry is the software that's used for slope deformation. So this is just kind of our general mining life cycle. You'll see Vulcan and other software that a lot of you've probably utilized before or have some exposure to. So just wanted to talk about the industry itself on the TLS laser scanners there. So Maptek there on the right side, that's our XR3. It's a extended range generation 3 scanner. We're now on our 3rd generation set of scanners. So the XR3D standing for dual window, it actually scans out both sides of the scanner head there you see in that image. That's a GPS head mounted to the top. So that actually is what geolocates all of your scan data. So mine sites are using that to actually physically locate their scans in real space to for the downstream process, making sure all that data is accurately placed using RTK GPS systems. Other manufacturers are listed there. There's certainly a whole suite that's not comprehensive by any means, but those are certainly other laser scanners that exist. On the terrestrial laser side, there's certainly other manufacturers out there with aerial LiDAR and even photogrammetry out there as well. So if you're not familiar with TLS scanning or the terrestrial laser scanners, and what they actually are, I just kind of wanted to give a real quick brief overview of the actual technology. It's time of flight. So what that means basically is the laser emits a pulse of light, and there's a detector within the scanner head itself that gets the return from the laser, and the detector measures the amount of time it takes to return. So that's actually gives you the actual point cloud, 3-dimensional point cloud that's provided as a result. So it's also line of sight. So there's certainly pros and cons that we'll talk a little bit about with the terrestrial laser scanners maybe versus aerial. A lot of them are probably obvious, but certainly one of them is line of sight. So where the scanner sits is certainly what you're going to see as far as the point cloud data that's returned. So the image on the right kind of is just a real basic example of a laser scanner there, kind of set up on a tripod. You can see some red dots, and that's the data it's going to collect. There's occlusion if if your eye can't see it, neither is a laser scanner. So just kind of some basic stuff on the time of flight TLS scanning. So I guess kind of jumping more into the geologic mapping side here and kind of really getting into the purpose of the discussion today is kind of talking about my experience maybe with traditional open pit high wall mapping at a mine site. So, for me, that was kind of, I guess the kind of colloquial term is chain style mapping or chain mapping, where you're getting your paper, pencil, maybe some colored pencils there and your clipboard, getting out there with your tape measure and your pocket transit. So for me, that was a Brunton compass, pretty standard out there, I think, for most. There's some others that people do prefer to use, but in general, that's what's being utilized. And in general, I would say that it's fairly low accuracy. Some might argue against that, but if you were to have a set of multiple geologists go out and map the same high wall, you may see some slight differences in a couple feet, maybe 1 or 2 feet either way, if you have really good mappers. So it's in a way somewhat low accuracy, and it's somewhat open for interpretation as well. It's single point measurements specific to you taking strike and dip measurements with your transit. So that's just something to keep in mind. And as you're mapping, it certainly doesn't mean you shouldn't do paper mapping, but we'll talk a little bit more about that as well. And I would say, at least for me, it was certainly a bit tedious to go from a paper map to software digitization. So I think that's relatively standard out there, where if you are still doing paper mapping, you're going to be transferring that to some sort of software to have that digitized to bring value to downstream solutions, such as your actual geologic models. So just something to kind of keep in mind there. And there could be some benefits to utilizing maybe a bit of a hybrid of your traditional paper mapping and comments you wouldn't be able to collect potentially with a laser scanner, as well as the accuracy that we're going to be getting into that really the laser scanners provide. I think us jumping into the software is really going to kind of showcase that specifically. So you got David Brunton over there with his pocket transit back in 1894, and I still do love using those. And maybe a little bit of a exaggeration there with the person there under a high wall, where ultimately, if you are doing paper mapping, you are spending more, there's extended exposure time on the high wall, certainly. And that, getting close to the face, if you're taking actual measurements on the rock outcrop itself, that's certainly putting you in close proximity to rockfall or just dangerous situations. So I know today, certainly in the industry, the mining industry, there's site regulations on working near high walls now. So it's becoming less common where geologists and geotechs are spending extended periods of time at the high wall. So it really kind of opens the door for technology to help with some of that. And again, not all of it, right? I don't want anyone to think that, and I think it's pretty reasonable to understand that, laser scanner is not going to do the all the mapping completely for you. The interpretation, you need to know your rock types and alteration types and get rock samples there. That's certainly something that's still going to have to occur. It's not going to do all that for you. So I wanted to talk a little bit about different types of data collection. So, today, at least for terrestrial LiDAR scanning, of course, this is kind of excluding aerial collection, but that's usually collected via tripod or vehicle mount. So, at least with our scanners and with some of the others in the industry, you can attach those scanners to vehicle mount systems that allow you to do stop and go scanning and even continuous scanning to capture the point cloud data. Other methods are also setting it up on like a fixed bollard for maybe more of the monitoring side, that we'll talk a little bit about too, how you can take these point cloud data sets and compare them to one another to measure deformation and velocity with point data. So those are just a few different ways of collecting data. So, let's talk a little bit about the Point Studio software and just general mapping, mapping capabilities and just the overview. So, after the scan data is collected, you can import all of this scan data directly into the Point Studio software, which I'm going to show you guys here in just a little bit. We'll actually get into the software and look at some point cloud data and do some mapping. So in general, the laser scanners are going to collect that high resolution scan data. That's all going to be imported into the software. And one of the benefits with some of the MapTech scanners, and there are others out there as well, they can provide those georeferenced photos, and ours in particular with the most recent scanners, they're 147 megapixels. So they're really high resolution photos that you can use to do the mapping. So that is all three-dimensional data, of course, where you can map your lithology, alteration, mineralization. That's all going to be used for your kind of downstream model updates. So, and along with that, because you have the 3D data, there's other tools built in, geotechnical tools for extracting structural discontinuities. And those can be used for further geotechnical analysis, such as like kinematics and discontinuity spacing and just building out multiple joint sets, kind of like you see in the image there. So that's kind of just a basic, you see multiple joint sets in that image, and then some simple lines drawn on the three benches there, kind of just showing how you can use even just CAD, simple CAD line drawings to project out a contact trace. So here's an example, just a quick screenshot of some high resolution scan data. So you can kind of see it looks kind of maybe pixelated, but those are all individual points colored by RGB. So because the photograph is georeferenced to the point cloud data, that's how you get the RGB values on each individual point. And from that, you can actually create, at least within the Point Studio software, what's called a scan triangulation. So basically, we'll take your point cloud that you see there, and then essentially just triangulate it to create that DTM surface. That's nice for exportables outside of the software. And it's all georeferenced, so there's a lot of downstream usage of that DTM surface, even outside of mapping. And then from there, this is just a simplification, taking essentially a point selection from that surface or point cloud to really extract discontinuity sets. So that can be done across entire sets of scans across an entire pit, and we'll talk a little bit about that. I'll actually provide a case study on that for you guys as well. So some of the geotechnical tools that live in the Point Studio software, at least, are simple structural orientation extraction that we kind of just showed with dip direction, strike, trend, plunge. All of that discontinuity data can be brought in to create stereo nets and rows diagrams. So that's used in downstream, kinematic analysis and visualization of the data that's been extracted. So over on the left side in that image, you can kind of see some kinematics with, this one in particular was a planar failure, and in red is kind of the critical region where if you have any structures falling within that, those are likely or more likely to be unstable or fail. From there, there's other tools such as cell mapping, where you can take the discontinuities mapped and bring those into some cell mapping tools, and then kind of down from that, creating solids from the surface outputs, that we just looked at. You can create wedge solids and things like that from that 3D data. That can be used to measure volumetrics and those sort of things, or tonnage of wedges that have either failed or could fail if you have some idea of orientation on those structures. Discontinuity spacing would be another one for your waviness. And then maybe one of the important items here is the exportable out of the software. It's great to be able to do all your analysis in an individual software, but there could be other software packages that are being utilized, and that's pretty common. So it's important to have, a wide suite of exportables. And some examples are CSV and OOT surfaces going out, and DXF, those sort of planar exports as well to go to other software. So here's just a kind of further, I guess, image of kinematic analysis and the software, where you're just looking at kind of a reporting of the point cloud data in that critical zone, and then it gives you a small little analysis properties down at the bottom there, showing you, how many critical poles out of the total in a discontinuity set and percentage live within that critical region. And then cell mapping. So I mentioned that. Here's just some images to kind of show that and follow up with that. Essentially, you can build a series of cells along a toe and crest line. This is obviously for open pit application. And those cell runs can analyze those specific groups. You can build those out as wide and as tall as you need based on the actual cells that you're analyzing. And take the discontinuities that you've already mapped, and you can assign all those structure sets directly to those cells. So you can do your kinematics and other analysis directly within the cell, not over a large area. So that's kind of the purpose of the cell mapping. And I guess I will mention with the cell mapping, this is using, of course, 3D and this digital data, right? So there's certainly, just like the geologic mapping, there are things you're not going to be able to capture without being in the field or having some understanding of the material itself. Maybe there's fracture filling. You may not get that from your scanning. So I also think it's certainly worth mentioning that that the 3D scan data it can definitely be used far beyond just general survey and mapping tasks that we've kind of talked briefly about. Here's another example. It's called Interamp Compliance. It's a module within Point Studio, and basically the Interamp Compliance tool is a slope optimization tool that's used today in many slope steepening projects and pushback advances, mainly because adherence to slope design and the operational mine environment is pretty crucial, right? So this is just another tool utilizing the same 3D data that you're capturing for your mapping to do some design compliance. So this is a helpful tool for geotechs in particular, and engineers to understand where their design compliance is at. So I guess just a couple things on this one. You kind of see the customized section profiles on the right side. It kind of gives you the as-built profile versus design, catch bench width, effective catch bench width. And then over on the left side, the surfaces that are generated from the point cloud data can be used to basically colorize the surface based on the compliance thresholds. So your catch bench width, bench face angles, all of those, you can kind of set up your own legends that kind of color code your surface based on its compliance. And the section spacing, of course, is something that's all user defined as well. So just a helpful tool to know that's out there, kind of making your life a little easier for doing your design compliance. And those legends are, again, customizable. So we have green being good in this particular case, orange is maybe okay, and then red would be bad. There's only a couple spots on that surface where you might see that. So like I mentioned, this tool reports on effective catch bench width and cumulative frequency percentage. You can also do reliability percentage as well. So it's going to give you an overall summary report. So this is a reporting tool along with it creating the 3D outputs such as the surface and as-built sections. It also creates that overall summary for you where it gives you your bench face angle, catch bench width, effective catch bench width, and then your Interamp angle from wherever you've done the analysis. So from your toe of the lowermost bench to the uppermost, wherever you're doing your analysis. And then kind of just showing the plots, the histogram plots it creates you have your effective catch bench width and bench face angle there on the right. One other thing I guess I wanted to show, this is kind of just neat. We're going to jump into Point Studio now and have a quick look at that. But let's see here. Let me pull up. If anybody is going to be making it to SME, it's in February 27th through March 2nd. There's a lot of great talks there, of course. But if you're going to make it there on Monday, February 28th, in the mining and exploration management, excuse me, is that the, yes, that's correct. So within that group, we're going to have it at 5 o'clock. There's an interesting talk in there on this Interamp Compliance tool, actually, how it's being used with drone data. So, some differences in, how you might utilize, vehicle or tripod mounted LiDAR that we're talking about today versus drones. There's certainly pros and cons to each, but it's an interesting talk on that specifically. So let's jump over into Point Studio. So this is kind of the fun stuff, right? We get to have a look at some of the data. I just have a single bench here just to kind of showcase some of the tools that we just talked about at a basic sense. So if I zoom into this point cloud, I hope this is easy to see on your side. Sometimes increasing the point size helps, but you can kind of see, I'll try to rotate slowly here, but you can kind of see the detail that the terrestrial LiDAR scanners can provide, specifically on bench. If you start scanning upwards, you might have some shadows, but that's an application where the long range scanners scanning from vantage points where you can see all of the benches is advantageous as well. So just kind of wanted to show some of the high detail and very close point spacing you could expect to get from some of your terrestrial LiDAR scanners. And this one is that XR3 or that Maptek extended range scanner. But from this, we can take this, and I had talked about, taking this point cloud and creating that scan triangulation. It's all really easy to use. The software is really user friendly. I can take it, and I can do what's called a point cloud connection. Now it looks like, if I zoom in, it looks like we have a photo drape over this. And it's actually an RGB color smoothing on this now connected point cloud. So from this, you could export a true DTM surface if you needed that. But you can utilize this to start doing some of your mapping, both structurally, getting your structural orientations, but also taking this and doing some of your CAD mapping for geology, your lithology, alteration, and mineralization as well. So yeah, let's just kind of jump in, and I'll show you some examples and some things that I didn't mention in the PowerPoint per se, but are other ways to visualize this data outside of just photograph. So let's have a look. Maybe we'll go ahead and start with just doing some of the general structure extraction. So our geotechnical tools, a lot of stuff in here. We'll just kind of briefly go over some quick things. We can make a quick point selection on any area. So, of course we could extend that out, but if you make a selection on a plane, you can go ahead and extract the orientation on that. So I can just hit query, and it's going to give us the strike and dip. So 297, 54, it's giving that orientation on that plane. If I wanted to extend that out to a larger area, we have tools built in here for that. You can use the extract tool. You'd select the scans. It can be multiple scans, so you could start to do this across a much larger area. And I'll give a case study actually from December of just this last year, where an entire mine site was mapped using this tool structurally. So yeah, with that selection, you can start to see other planes at that same orientation. So it extracts those for you. Now, of course, you have to be careful. This tool, it may extract some planes that aren't real, and there's other tools built into the software, such as Merge, that allows you to take discontinuity sets that maybe have some overlap. You might be mapping a structure that by, visualization, zooming in as one structure, but the algorithm picks up maybe two. you can merge those together to create one plane as you would maybe map it with your Brunton in the field. So there's some smart tools in there to kind of help with some of that bias. You can control your angle thresholds and area sizes of those structures that it's extracting. So that can help if you have, broken zones, really small structures potentially. You can really reduce the minimum area that you're searching across. But maybe you want bench scale structures. You could, increase that minimum area up quite a bit to get those larger structures extracted as well. So, for this simple example, I'm just going to hit OK, and it's going to go ahead and generate a discontinuity set for us. And you can rename these, right? It's just discontinuity set, but these are simple. We could rename this joint set 1, right? And you can set attributes to these as well. And they're all exportable outside of the Point Studio software. Like I mentioned, you can just simply select the discontinuity sets and go to export and get them out of the software as text files, custom text files, where you can actually control what you want, what columns you want exported. So it's kind of cool. Pretty easy to use, pretty easy to export out. But this is a very commonly used tool out in the industry. So I'd mentioned different color options too, outside of just photographic, right? That's what we're looking at here. So let's go ahead and have a quick look at that. This is pretty awesome. I really do like this tool a lot. It allows us to change the color of this particular scan. So we'll go over and I'll go to my color scheme and we'll set it up as, let's go with hot intensity. So this really helps to potentially, alteration or lithology differences. So you get a different return. There's an intensity value that's returned back to the Maptek scanners that allow you to kind of map by intensity value. So, basically differences in color of the material are going to give you different returns on this hot intensity mapping. So, for mapping geology, I showed basically from a basic sense how to do some structure extraction from geologic mapping standpoint. And by that, I mean lithology and alteration and mineralization, not so much the structure. We can come in and we can map, we can use our polygon tools, and we can simply just map out, this is a simple way. We have some other smart tools to follow along trace differences between color, but that's a simple way to draw a, 3-dimensional polygon on your face. And, as of right now, that's only just a polygon, but we have layer and feature tools that allow you to set up customizable, basically look at it as kind of a geology library. So you could have all your alteration assemblages, all your rock types built out into features that you'd have drop downs of, and assign those accordingly as you map, so that everything is being assigned based on that feature. And that is obviously important if you're taking this information out to, like I had briefly mentioned, other, general or GMP mine packages like Vulcan here, where you could bring that data mapped over into Vulcan, because it's all on this workbench now, a single set of platform for the applications here. So yeah, I thought that would be kind of cool to show. It's pretty easy to use stuff. And I don't want to exclude anybody on the underground side here. So the same goes, right? We have an actual underground scanner as well called the SR3. It's a short range scanner, but no difference there in how you would go about processing this. So here's just an example of the end of a drift, right? And same thing, you can see the structures. I can come in and do the same exact thing where I do that connection. And you can start to see those structures. You can map, you can do line mapping as well, because this is 3D. Let's say you don't have surface relief, like we do here, but let's say you don't have that, or if there's a faint contact, you can map out a CAD line, and then because it's 3D, you can get an orientation on that contact too. So just wanted to kind of show show the underground side as well. All right, well, I think we'll go ahead and jump back into our PowerPoint. And yeah, if you guys have any questions at the end, can definitely answer anything on that Point Studio side. I know that's cool seeing the visualization in 3D there. So what I wanted to jump into now was really more on the the slope deformation monitoring side. So that same sensor or instrument, the Maptek scanners, they can be mounted on this it's called Sentry. It's our slope deformation monitoring system. Basically, this system that you see there, that trailer is got a hydraulic tripod that drops down. You can mount the scanner, and it does all your continuous monitoring for you. So it's collecting scan data, and it's comparing those scans together. And we'll talk kind of more about what Sentry is here too. But just wanted to give you a visual image of what, at least what a slope deformation monitoring system using LiDAR would look like. So this one has like a generator, a battery bank set up, and solar panels, weather station, all of that kind of inbuilt. It really is kind of a completely self-contained monitoring system. So just a quick overview of what Sentry is. So I kind of went over that, but it's of course the integrated hardware and software solution. So the integrated hardware is that deployable monitoring system, or Sentry DMS, that I just showed you, the trailer, and the scanner. So it's paired with that LiDAR scanner. It's removable. You can put that on the tripod and remove it for other uses, such as putting it on maybe a vehicle mount and going and collecting data for pit mapping, those sort of things. So it's kind of allows you to use one tool for multiple applications. Now, of course, you wouldn't be doing monitoring at that point, so something definitely of consideration there. And then the software part of this is really just Sentry, the Sentry field software, as it's called. So over on the right side, that's the visualization platform for your monitoring. So it's 3D visualization, although the image there that you see that basically has the different colors on it, the color heat map is showing a specific failure event that's about to occur. This one was actually predicted, and it shows you the movement towards us in the warmer colors, and then the movement away from us is like the blue, the cooler colors. So this was actually a planar failure that occurred, but kind of looks like a rotational failure here. But what's cool is you can actually bring this into three-dimensional space, this particular view, and you can see, you can see maybe some of the mechanics of the instability that you might have. So it's just a scan-to-scan comparison at kind of user-defined intervals. Again, it can be periodic or continuous monitoring, but that's kind of up to the user. On from that, you do have your real-time alarms that can be set up and sent out via email and text message, and that's through displacement velocity and inverse velocity. So you can kind of see on the bottom part of that 3D panel, we have displacement shown, an increase in displacement, of course, for this this particular kind of slump. And all of that can be set at user-defined alarms to notify whatever users are a part of that chain. So, how does it work? Well, I described a little bit, but essentially you're going to be capturing your scan data either via that deployable monitoring system trailer, the hydraulic tripod that's independent from that trailer also. So it's, if that trailer moves, the hydraulic tripod is separate from that. Or, fixed bollard style monitoring, where you set up your scanner on a fixed monument in a monitoring shack, and you collect your data. Again, periodic or continuous monitoring, however you like to set that up, could be based on how you might be using your scanner for other tasks. But you would be creating specific zones of interest within the Sentry software that basically are defined areas where you can set up your user-defined alarms. And then from there, you will get movement detection alarms that come through based on those thresholds. And you can analyze that data. You can back analyze it as well. So you can take up, of course, all that history of scan data that you've collected, and you can do some back analysis on failure events that have occurred, maybe to help you going forward with similar rock types or material types where you might have the same kind of mechanics, and that might help you understand maybe a little bit better refining some of the TARP thresholds and those sort of things with some of the analysis that you can do with the software. And I would say one of the things that's also fairly unique to LiDAR with slope deformation monitoring is rockfall detection, because you're capturing individual scans and you have that library of scans, and the spatial resolution is very small. You saw how resolute the point cloud was just in, maybe that was a bit closer, but you will see a fairly resolute point cloud data set, and that helps you really detect potentially precursor events and just rockfall source and accumulation zones, of course, that you can kind of see in these images, the left being 3D view in Century. So they're individual cells that you see. Those squares are cells of 36 points per cell. The spatial resolution or the size of those cells is going to be really dependent on your range, but it kind of gives you an idea of what that resolution could look like and how it might pick up some of those rockfall events. And then from there, measure some of the rockfall runout and potentially volumetrics and tonnage of not just rockfall, but anything that's occurred on the from your monitoring. So with that, I guess I just wanted to kind of close out. This was just an overview on generally how you could use LiDAR for mapping and slope deformation, but I wanted to give a couple case studies and some resources for you guys to have a peek at, and these are on our website. There's a case study that was done at Buena Vista del Cobre. That was actually this last year in December 2021 between Maptek and SRK, where they did an entire pit structural extraction or model. So we'll go take a quick look at that here in a second, but also other what we call mine measurement case studies. So that's anything really to do with terrestrial LiDAR instruments and the Point Studio or Century software. So let's have a quick look at that. I'll just show you where they're at. I mean, right on our website, but I'll just show you some of those items. So here's the mine measurement case studies. You can get to that. There's a couple different ways, but if you go through the operations and production tab, you have Point Studio and laser scanners here. You can click on Point Studio, and the nice part is you just scroll down and it'll take you to the case study. So everything that I kind of was talking about here, a lot of different stuff in here, open pit and underground applications, and how even some of this stuff can be built into what are called workflows, where a single task can be simplified or streamlined into, kind of clicking play. It runs through it's basically, look at it as kind of like a script. It'll run through your task, and all the individual clicks you might be doing in the software have been brought into a single kind of streamlined process for you. But yeah, have a look at this. There's a whole lot of stuff in there, all kinds of different underground applications. And actually in here was actually most recently is that Buena Vista del Cobre case study. So that can be found in that case study location, or you can go to resources, Forge newsletter, and this has a lot of the most recent case studies and work that's been done. A lot of stuff in here, even using some of our other geology tools on the mine planning side or the GMP side there, but you can click on this data collection analysis and it'll just give you the case study that was done, and how it was done and what value it brought this particular site on doing their structure mapping. I showed you a basic single high wall, but yeah, this is how it can be done for an entire pit. And I guess with that, I don't really have anything else for today. I guess we could open it up to questions. Before maybe we jump into questions exactly, I just wanted to say for contact information, you can reach out to me directly. There's my email address. But for any students that are really interested in this, I do want to mention that we do you do at CSM have free access to this software. So I would highly recommend taking advantage of that. And you can reach out directly through that uni.support@maptech.com. Talk with your your professors, advisors about this too. I think there could be some value in utilizing that for you guys there. And if you need the direct U.S. account manager, that is Maureen Moore. So she will get that email here in Denver. It's also where I'm located. Yeah, definitely appreciate everyone's time. And yeah, I guess what questions are out there?
Thanks so much, Aaron. That was a great talk. And thanks for walking us through the actual software. I think it was really helpful to see what kind of capabilities MapTech has there. Let's see.
Yeah, no problem.
There are a couple questions in chat. The first one being non-technical, and that's if you're willing to share your slides with us after.
Yeah, absolutely.
Well, thank you. And the second one being technical is if you can repeat information about classified points. Not sure if maybe you can correct me if I'm wrong there, Sylvia, but I think that's in regards to the classification of like the different planes, like using the feature and layer.
Yeah, maybe I can kind of jump in. I can see maybe that going a couple different ways. What we can do with point cloud, the point cloud itself, is we can attribute. So let's say that you had a point cloud that had vegetation and topography. You could select the point cloud data that was let's say vegetation, and you could attribute it as vegetation. So there is a way to essentially classify it in that way through attributes within our software, if that's what you're referring to. If it's more on the features with the geology mapping, just let me know. I can explain that.
Thank you. Yeah, let's see if she adds another comment there. I have a question for you in the meantime. There's when I worked at a mine, I would often see a lot of the fault planes or joints kind of carrying different fluids around, whether it was like pregnant leach solutions or groundwater. And I always wondered if that made it more prone to slip. And I wanted to ask you, in that structural analysis where you have the stereo net and the critical zone, do you ever see those faults with the solutions being more prone to fail, or is that not really seen?
Yeah, I mean, absolutely. As the pore pressure increases, it's certainly more likely to fail. One of the things I guess I failed to mention there is, I guess I showed the hot intensity, in its use for geologic mapping. But if you have, let's say, a tailings dam that has maybe, let's say it wasn't properly lined, or there's some water coming through even the tailings dam, the saturation of material also affects the intensity values that come back, and that'll come up when you look at the material or look at the point cloud. So that wouldn't necessarily be an application for the stereo net, but you can use intensity mapping for changes in saturation of material. So in the stereo net itself, I guess it's not necessarily identified per se, because it's more based on the orientation, but it is something that going forward, even the Century software, on the deformation side with material moving, intensity value could be something that's also mapped.
Okay.
So I hope that answers the question.
Yeah, it does. I really just would see those faults, and I was like, I wonder if that's actually really dangerous. And I think at its basis, yes.
Yeah, definitely. If there's water, I mean, that would be a good thing or not a good thing, but if you saw the water in the scan and there's a large fault there, certainly could be a precursor event.
Thanks. We got another one here from Melissa, and that is, so there's no ability to classify the LiDAR points with the terrestrial scanner? That's the first part of the question.
Yeah, so there's no point classification that automatically occurs with our software or the the scanner. So it's all attributed post data collection. That's correct.
And the second part is any type of classification or attribution only done post data collection in the software?
Yep. So it's all post data collection.
And another question here is, with the laser scan, as you mentioned, there will be shadows and structures depending on the angle of the scanner at the high wall. Can the software stitch together scans from multiple angles to remove shadows?
Yeah, absolutely. I just showed one individual scan, but ideally you're taking scans from multiple orientations. So, like I guess for the Del Cobre example there, certainly scans taken from all across the pit to build that structural model. So you can use multiple scans and use that in the structure extraction tool to account for any shadows that you might have from one individual scan. So that's something that can definitely be done with Point Studio and the laser scanner.
Awesome. Yeah, I was actually wondering about that because of the RGB example you showed with where you can see different rock types based on color. I was wondering if the shadow would impact that, but I guess you get around it with multiple scans.
Yeah, definitely the shadow could affect that, certainly. So you can do kind of some tile and tie if you have multiple screens, is what it's called, and you can look at the point cloud side by side with the heat map, and you can rotate and kind of see maybe, okay, this area is being affected by a shadow. But if you have multiple scans, then it's really not much of an issue there.
Okay, thank you. I guess I was also wondering if MapTech allows or has the capabilities of using data from like aerial taken LiDAR, and then you can interpret it in MapTech. Is that a capability, or is it only from on the ground?
No, Point Studio can really analyze and import really any point cloud file. So in LAZ, LAS, E57, XYZ, point cloud, those are just common file types from other vendors. You can import that from other terrestrial LiDAR sources or from aerial LiDAR or photogrammetry platforms as well, outside of LiDAR too.
Awesome.
Okay. I've got a question.
Yeah, go ahead.
Do you have anything on public data that relates to the big slide in Bingham Canyon 2014? And of course, the later monitoring to prevent such another slide. It was such a spectacular slide, and it wiped out, I don't know, many millions of dollars worth of equipment because they didn't realize how far it would go. I'm wondering what ways you might apply something to continuous scanning in an open pit mine, and if there's anything on Bingham as to what proprietary maybe they're doing over there to prevent such things.
Yeah, so nothing, unfortunately, I can talk about. It's not public information, so I can't talk too much on it. But in general, yeah, with large failure events like that, the continuous scanning, if it's within range, that's a very large pit, can certainly be captured and then used to alarm on any deformation that's occurring within a threshold that the user sets.
Well, the follow-up on that, just as a geologist, I looked across the pit in 2014, about 10 days after it slid. You could see how big the pit was and all the damage, the little things that looked like the back leg of a cockroach poking through the slide. And that was really the boom of a shovel or a drill. And then I went back there about 2 years ago, same private property, someone else's claim, across the pit from the southwest. And you could see the pit was probably 1/3 deeper. And the feature that stood out most is the same linear that goes through all of the major porphyries that are actually mineable in Utah. It's about North 50 East. And there's a plane in the side of the pit that is that, and there's a huge exposure of that. So I suppose with your kind of system, you could scan that constantly. You could have a monitor set up in the right place that would scan that and tell you if something was moving, because obviously water runs down a great deal, I would assume in the winter, it just comes right off a mountain. How would you set that up as a permanent station that transmitted to somewhere?
Yeah, so it's basically wherever the trailer's set up. It's basically going to be in communication through either an in-pit network. They have their own, Wi-Fi or point-to-point link that allows the data transmission from that monitoring station to their either local network or outside of that too. So that's done through a variety of different methods. I can say with our system, we can really pretty much do anything as far as LTE networks. We have our own router set up on there. So if you have 4G, 5G network, you could use that. In-pit Wi-Fi could be utilized, or like I mentioned, a point-to-point solution. So that would be kind of more of like a WAN, wide area network connection that's pretty common in connecting these systems to the the office and to the outside world.
Hey, well, thank you. That's and a great talk, by the way.
Yeah, thank you. I appreciate everyone attending.
Give it 5 more minutes for any more questions. Give a chance for the shy people to get their voice out. So I doubt this would be the case, but are there any initiatives about the structural data collected to make it public, or at least with the USGS, so that they can contribute to a larger database of regional scale structures? Or is there any way that data is being shared at all?
Yeah, interesting question. I would say mainly our systems are being used in the mining industry. So it is proprietary information or data. So I guess there are certainly case studies though, where, it has been used in either government agency or, even just Department of Transportation's, where that would be public, but I don't know if it's really being uploaded to any, I guess, shared platform. So nothing from our side, I guess, on that front.
Yeah, I figured, since mining companies don't really like to share their stuff, but the type of structural models that they come up with by the end of their mining term becomes really detailed. And I always think about how useful that'd be for at least brownfields exploration or anything regional scale.
It would be, yeah, absolutely.
Okay. I don't see any more questions rolling in, Aaron. Thanks so much for your time, and it was a really great talk. I really appreciate you coming out here and giving us that talk.
Yeah, absolutely. And thanks for letting me give the talk, and appreciate everyone's questions and attending.
All right, thank you.
Bye.